Hello! In this presentation, we're going to introduce you to our friend Poco. But first, let me tell you a short story. I'm a senior student and I should be meeting with my graduation team regularly to work on our graduation project. However, due to Corona, we can't meet on campus, so we have to meet online. We tried a famous app, but whoops, my screen froze several times and I couldn't connect. We shifted to another one. It kept telling me I have poor connection, so we chose yet another one, but I was not able to hear anything. Our experience was frustrating. Fortunately, this is the norm with nearly 23 million students in Egypt. Whether they are at school, trying to work on a school project, or university students trying to work on research and assignments. This made us think of how severe video conferencing is, and after a thorough research, we found out that by 2022, around 60% of the world population will be online. We also found out that 80% of internet traffic in 2022 will be coming from video conferencing and streaming. Wow, such a great number needs a reliable video conferencing solution. We then began to investigate the current solutions, and we found out that video conferencing relies heavily on the availability of efficient video compression standards, such as H.264. Although this video codec has been optimized and tuned for over 30 years, they are still unable to provide acceptable performances with limited bandwidth. And that is why we came up with PocoByte, which is a project that helps enhance video conferencing using AI technologies.
Let's discover the magic behind Poco. This is the core of Poco architecture. You will see a video example on our website. But let me first give you an overview of architecture. Starting from the left of the image with video input to the encoder part. Going to keyframe extraction, which extracting the main frame. Initially it will be the first frame of the video. Next we extract the features, which is the key point of main object. In our case it's a human face. Then save a copy of the buffer to be changed in case of losses increased. This happened in parallel of taking the main frame and compare it with the video input, which now we call a driven video, to measure changes between them. If changes were large, we will make a reset procedure, which will update the buffer content. If the losses were small, we will continue extracting key points and send them. Next stage, which is transmission data, and just notice that we only send one kind of data. It's the main frame or the key point. Last, we get our data and reconstruct the frame. This happens by generator that save a copy of the content of the buffer, which is the main frame, and get the key points and reconstruct the next frames. After reconstruction, we calculate losses, which is loss 2. Comparing original input with the output. If losses were large, we will apply a reset procedure which extracting the key points again. If the losses were small, we will reconstruct it with a good quality and output the video. This is the technologies that we use until now. For building the website, we needed Cloud Firestore, Firebase, WebRTC, Vanilla, and Bootstrap. For the core architecture, we use computer vision algorithms, machine learning, deep learning, especially CNN and GAN, and for evaluating, we use a tool called MCU. There are several ways of evaluation. We first choose the size of video. To validate our proof of concept, we made an experiment to compare between our model and H.264 codec. We used a video of 10 seconds with 256 resolution and the original size was 34 megabytes. After processing to our model and H.264, we got that our output video of our model had a size of 88 kilobytes and the output video of H.264 with about 288 kilobytes. Another way of evaluation to measure bitrate performance, we find that our model has lower bitrate on average. This image is taken from big signal to noise ratio test. We can conclude that our model get about 70% less than H264 in bitrate reduction.
So, who could benefit from PocoByte? We have three expected categories. First, we have corporates that had to move their work online due to COVID-19. Second, we have a startup that can't afford buying or renting a place to work in. Third, we have educational institutions that now depend greatly on e-learning. For further illustration, here is our business model canvas, illustrating our revenue streams which will rely on subscription to our web, mobile application, also on integration with other platforms.
For our marketing strategy, early market research and surveys helped us get to know our customers' exact needs and where we can fit in and improve the most. And as we found out, video conferencing was no longer limited to international meetings or video calls, but it became an errand that you have every day, whether it's for work, education, or even for entertainment. To start our campaign, we will launch a blog to introduce our application to users and highlight our strong competency of how our solution makes the difference in their new norm daily routines, through tutorial videos customized for our clients, whether they are normal users, business leaders and entrepreneurs, or large enterprises, and also allows them to track their savings and the amount of internet usage through our application. After we get yearly feedback and apply some improvements, we will enlarge our audience and start our social media campaign with our Ready to Conquer application. And as the research shows that the youth are the majority users right now, we will widen our reach to campuses and provide them with our designed packages for students and with some free trials. To measure our success, we set all the metrics and chose only the most important as our key performance indicators. And by periodically tracking the KPIs, we make sure that we are always aware of our target and check if we are walking on the right path or need to change our direction a bit. As our primary concern is customer delivery and satisfaction, we must ensure that by using our application, users save about 40% of money paid for internet consumption. Hence, we guarantee the increase of our Net Promoter Score. And by acquiring more customers, we expect a promising ROA, which indicates our efficient delivery.
This is our roadmap. We started by defining the problem, which is poor internet connectivity. After that, we moved to the research phase to find the latest developments in this field. At this point, we found NVIDIA's mixing solution, in which we got inspired by. Then, in the learning phase, we dig deeper in topics like deep learning and computer vision to better understand how to approach the problem and find possible solutions. In the baseline selection phase, we chose one of the models we found as a starting point so that we can build on top of it. After choosing a baseline, we started to validate our proof of concept in order to see how it performs and compare it to other models. Currently, we are building our first MVP in the form of a web application to better showcase our model performance in a real scenario. Our next step is to do more research, try other models, and enhance our current model to develop a better integrated solution. This is a short demo of our web app. It's a simple app that offers one-to-one meetings. As we mentioned, it's our first MVP. We work on developing a more advanced and secure platform in the future.
Hello, this is our PocoByte website. I'm going to show a little demo about how to use this website. First of all, I'm going to talk about the design of our website. The front end is designed using Bootstrap, and the part for the video conference is designed using WebRTC, and to manage the call IDs, we use Firebase. Now let's start and create a meeting, and a friend will join a meeting with me right now. Create a meeting. I'm going to start my webcam. I'm just using a virtual webcam not to show myself. Now I'm going to create a call and take this ID and send it to my friend. Now I will take this ID and send it to my friend and wait for him to join me. Hello?
Hi.
I can hear you well. Can you hear me too?
Yes, well.
Okay. This is just a virtual cam, not to show ourselves. Here we can show some features about our video and audio using WebRTC internals. We can see some features like the dimension, width and height, and frames per second, and etc. Many features right here. Thanks for watching.